In the previous class, we studied basic inequalities, and in this class, we further explore how to use basic inequalities to solve practical problems. Firstly, let's review the content of the previous class. Firstly, what is the fundamental inequality? The basic inequality refers to the condition that the arithmetic mean of two positive numbers is not less than their geometric mean. The basic inequality holds if both a and b are positive numbers, and if and only if a is equal to b, the root of ab is equal to half of a plus b. Secondly, through the learning in the previous class, we know that if the product of two positive numbers is constant, then their sum has a minimum value, and when these two positive numbers are equal, their sum is minimum. When the sum of two positive numbers is constant, their product has a maximum value, and when these two positive numbers are equal, their product is maximum. Please try to express the above two questions in one sentence using natural language. How do you think it should be expressed? Everyone should have thought it through. Simply put, when the product or sum of two positive variables is constant, their sum has a minimum value or the product has a maximum value. These are the two basic mathematical models for solving the extremum problem using fundamental inequalities. When using basic inequalities to find the maximum value, we must pay special attention to three limiting conditions: first, positive; second, definite; third, equation. Next, we will further investigate how to use fundamental inequalities to solve the extremum problem related to practical problems. Firstly, let's take a look at question 1. Regarding question 1, we have two sub-questions. First, let's take a look at the first sub-question. What is the shortest length of a fence used to enclose a rectangular vegetable garden with an area of 100 square meters? What is the length of the shortest fence? After reading the title, how do you consider this issue? According to the basic principles of mathematical modeling, we can generally transform an actual problem into a mathematical problem. Firstly, the solution to the mathematical problem can be obtained, and then it can be regressed to the actual problem to solve it. By examining the problem, it can be transformed into a mathematical problem, given that the area of a rectangle is 100 square meters. When asked what the side length of this rectangle is, its circumference is the shortest. Because the area of a rectangle is the product of its two adjacent sides, and the circumference of a rectangle is twice the sum of its two adjacent sides. The problem is actually that given that the product of the two adjacent sides of a rectangle is 100 square meters, when asking about the length of a rectangle, the minimum is twice the sum of its two adjacent sides. That is to say, regardless of how the two adjacent edges of a rectangle change, their product remains unchanged. Therefore, this problem can be further described as knowing that the product of two positive numbers is constant. What is the minimum value of their sum? Based on the above analysis, it is not difficult to think of using fundamental inequalities to solve this problem. Next, we will address the first question in detail. Firstly, we can assume that the adjacent sides of the rectangle are x meters and y meters in length, respectively. Therefore, the circumference of the rectangle, which is twice the length of the fence, is x plus y meters. Given that the area of a rectangle is 100 square meters, we can conclude that x multiplied by y equals 100. At this point, we know that the product of two positive numbers is constant. How can we find the minimum value of their sum? You should be able to think of using basic inequalities to solve it, because when the product of two positive numbers is constant, their sum has a minimum value. So according to the basic inequality, it can be concluded that x plus y is greater than or equal to twice the root of x multiplied by y. Since x multiplied by y equals 100, x plus y is greater than or equal to 20, so the double of x plus y is greater than or equal to 40. Can the equal sign be obtained? We can look at the initial use of basic inequalities, and we know that the equal sign holds only when x equals y, because x multiplied by y equals 100, and both x and y are positive numbers. So if and only if x equals y equals 10, the equal sign holds, and at this point, the minimum value of double x plus y is 40. Thus, we can conclude that when the rectangular vegetable garden is a square with a side length of 10 meters, the shortest fence is used, and the length of the shortest fence is 40 meters. By solving the first problem, we have gained a further understanding of the first basic model for finding the maximum value using fundamental inequalities. That is, when the product of two positive numbers is constant, then when these two positive numbers are equal, their sum has a minimum value. Next, let's study the second question. Please take a look at the question. What is the maximum size of a rectangular vegetable garden enclosed by a 36-meter-long fence? What is the maximum area? After reading the question, how can we solve this problem? This problem can be transformed into a mathematical problem. Given that the circumference of a rectangle is 36 meters, when asked what is the side length of the rectangle, the area of the rectangle is maximized. So this problem can be further described as knowing that the sum of two adjacent sides of a rectangle is a constant value of 18 meters. When asking what the side length of the rectangle is, the product of its two adjacent sides is the largest. So this problem can be further expressed as finding the maximum product of two positive numbers when their sum is known to be constant. Based on the above analysis, it is not difficult for everyone to think that using basic inequalities can solve this problem. Next, let's solve the second question in detail. Firstly, let's assume that the adjacent sides of the rectangle are x meters and y meters in length, respectively. Therefore, the circumference of the rectangle, which is twice the length of the fence, is x plus y meters. Given that the perimeter of a rectangle is 36, double x plus y equals 36, and the area of the rectangle can be expressed as x multiplied by y square meters. At this point, we know that the sum of two positive numbers is constant. How can we find the maximum product of them? It is not difficult for everyone to think of using basic inequalities to solve this problem, because when the sum of two positive numbers is constant, their product has a maximum value. So according to the basic inequality, it can be concluded that xy under the root sign is less than or equal to half of x plus y. Substituting x plus y equals 18, we can conclude that xy under the root sign is less than or equal to 9, so x multiplied by y is less than or equal to 81. Can this equal sign be obtained? Let's still look at the initial use of basic inequalities. We know that the equal sign holds only when x equals y, because x plus y equals 18, and because both x and y are positive numbers, the equal sign holds only when x equals y and equals 9. Therefore, it can be inferred that the maximum value of x multiplied by y is 81. Therefore, we can conclude that when this rectangular vegetable garden is a square with a side length of 9 meters, the vegetable garden area is the largest, and the maximum area is 81 square meters. At this point, I would like to ask everyone a question. Why is it necessary to prove that the equation x equals y and equals 9 holds in order to say that the maximum value of x multiplied by y is 81, and thus arrive at the final conclusion? Think about it. I think everyone has already figured it out. To explain this issue clearly, we must understand the meaning of the maximum value of x multiplied by y being 81. Its meaning is that for any x or y that meets known conditions, x multiplied by y is less than or equal to 81, and there are x and y that meet known conditions such that x multiplied by y equals 81. So for this problem, we first derive from the fundamental inequality that x multiplied by y is less than or equal to 81. In order to clarify that the maximum value of x multiplied by y is 81, it is necessary to explain the existence of x and y that satisfy the known conditions, such that x multiplied by y equals 81. It can be seen that it is necessary to determine whether the equal sign holds when using basic inequalities to solve the problem of finding the maximum value. Let's stop here for this question. By solving the second question, we have gained a further understanding of the second basic model for solving the extremum problem using fundamental inequalities. That is, when the sum of two positive numbers is constant, then when these two positive numbers are equal, their product has a maximum value. Let's further investigate question 2. Firstly, let's take a look at the problem. A certain factory wants to build a rectangular uncovered water injection tank with a volume of 4,800 cubic meters and a depth of 3 meters. If the cost per square meter of the pool bottom is 150 yuans and the cost per square meter of the pool wall is 120 yuans, how can we design the pool to minimize the total cost? What is the minimum total cost? Firstly, please think independently and if necessary, draw a geometric diagram. Then, let's study this problem together. After independent thinking, let's take a look together at how to solve this problem. Firstly, we can draw a schematic diagram of an uncovered rectangular water injection tank. Given its volume of 4,800 cubic meters, the volume of this rectangular tank is equal to 4,800 cubic meters, which is the product of its length, width, and height. Because the depth of the pool is 3 meters, the length multiplied by the width of the rectangular prism should be equal to 1,600 square meters. At this point, we can introduce two variables. Let the length and width of the rectangular prism be x meters and y meters respectively, so x multiplied by y equals 1,600. Next, we can know that the total cost of the pool is determined by the pool bottom area, which is the bottom area of the rectangular prism, and the pool wall area, which is the side area of the rectangular prism, as well as their corresponding unit prices. Since the height of the rectangular prism is known, the total cost of the water tank can be determined by the analytical expressions for the length and width of the rectangular prism, that is x and y. So that we can further study the minimum value of the total cost of the water tank, let's solve this problem in detail below. Firstly, we can set the lengths of the adjacent sides at the bottom of the injection tank to x meters and y meters respectively, and the total cost of the tank to z yuan. As we know, the total cost z of the pool is equal to the pool bottom area x multiplied by y multiplied by its unit price of 150, plus twice the pool wall area 3x plus twice the pool wall area 3y multiplied by its unit price of 120. After sorting, we can conclude that z is equal to 150 times xy plus 720 times x plus y. Given a known volume of 4,800 cubic meters, multiplying x by y equals 4,800, so multiplying x by y equals 1,600. Therefore, we can conclude that z should be equal to 240,000 plus 720 times x plus y. To find the minimum value of z, based on the basic properties of the inequality, we can simply determine the minimum value of x plus y. So according to the basic inequality, we can obtain x multiplied by y at the root of x plus y greater than or equal to twice. Next, based on the basic properties of the inequality, we can multiply both sides of the inequality by 720 at the same time, without changing the direction of the inequality. Then we can add 240,000 to both sides of the inequality at the same time, without changing the direction of the inequality, so that we can obtain xy at the root of z greater than or equal to 240,000 plus 720 times. Substituting x multiplied by y equals 1,600, we can obtain z equal to 297,600. Can the equal sign be obtained? We can determine that the equal sign holds only when x equals y. After calculation, we can conclude that x equals y and equals 40. Therefore, we can conclude that when designing the bottom of the water injection tank as a square with a side length of 40 meters, the total cost is the lowest, with a minimum total cost of 297,600. By solving problem 2, we once again went through the process of solving practical problems by reading the question and understanding its meaning. Based on the basic ideas of mathematical modeling, we transformed the practical problem into a mathematical problem, then solved it using the basic model of basic inequalities, and finally regressed the mathematical problem to the solution of the practical problem, thus obtaining the design scheme of the practical problem. At this point, I would like to ask everyone, can you design a practical question about the optimal value problem yourself? And solve it. You can change one or some of the conditions in question 2 above, or design another question. I think some people have already designed it. We can change the volume from 4,800 cubic meters to 6,000 cubic meters in question 2, or we can change the cost per square meter of the pool bottom from 150 yuans to 180 yuans per square meter of the pool bottom, and so on. So, let's leave this question as a post-class exercise for everyone. Finally, let's summarize the content of this lesson. Firstly, through the study of this lesson, we have gained a deeper understanding of fundamental inequalities and appreciated their functions. Secondly, by applying fundamental inequalities to solve the extremum problem in practical problems, we have gained a further understanding and application of the two basic models of fundamental inequalities. Thirdly, by applying fundamental inequalities to solve practical problems, we have gone through the basic process of mathematical modeling, experienced the basic ideas of mathematical modeling, and improved our mathematical modeling literacy.